Now we'll go on to the last unit, which is Unit 11. Okay, so it's about a bird. And so the Australian brush turkey and some other birds. So no surprise, birds, fish, and bats. And in it, they talk about, the first paragraph says the noun temperature is below stable incubation temperature. Rate of heat production, blah, 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 but the reverse is true about the incubating temperature. As soon as you read something like that, you have to double underline it and put a star next to it because you probably have to come back to it. Because if there's one thing ACER loves, are opposites. So anytime you hear reverse or, you know, there's an inverted something or upside down, whatever it is, they love to ask questions like that because, you know, you have to think backwards, basically. And so that's a source of many questions. And then blah, blah talks about gas and air and whatever, 17% oxygen. And, you know, even though they wrote it here, you should probably have an idea that oxygen in air is approximately 21%. Most of air is composed of nitrogen, N2, which is about 78%. And then 1% or less of air is this combination of other gases, including, of course, carbon dioxide, which is in very small quantity in normal. Okay, so they talk about the eggshell and talk about the chorion membranes. And for many of you, this first time you've seen that, trust me, it will not be the last time. You will read about chorion membranes on multiple occasions because those membranes are the placenta of birds, and that's where a lot of fusion and products that the growing embryo require and needs to get rid of passes. And so for that reason, it comes up in passages in units among the exams, and you'll see it again in ACER practice questions. Okay, and then you have a couple of diagrams, sort of sigmoidal in shape as you look at them, so it should remind you of oxygen curves, hemoglobin curves, also titration curves in general chemistry have a sigmoidal shape. Okay, and you also observe that in the diagram there's one x-axis, but there are two y-axes. So that's, you know, after a while of giving you an x-axis and a y-axis, ACER gets a little bored, so they give you two y-axes or maybe two x-axes, which we saw earlier. Sometimes they can give you an x, y, a z-axis, so a three-dimensional curve. And then the questions will be based on the same things, which are something to do with the x or y-axis or something to do with the slope, which is delta y over delta x, which is rise over run. It's very important that you know slope, and you can evaluate the units to determine if the slope gives you anything of value. It does not for this particular situation, but there are questions like that. That's why it's important to practice. And the area under the curve, very important. And you can know what an area under the curve gives you by looking, again, at the units of the x and y axis, because the area under the curve would be x times y. Just like a box or a square, you multiply one by the other. And we might have a chance to do that shortly. So question number 32. According to figure 1, on the following, which is the greatest total amount of oxygen consumption. Now, looking at figure 1, you see that the oxygen consumption that we're given along the y-axis is actually oxygen per hour. So to get the total oxygen consumption, we would have to multiply the oxygen consumption per hour times time. By multiplying it by time, we can eliminate hour, and we would have the true oxygen consumption. So, and that means, by the way, since the x-axis is time, we are multiplying the y-axis by the x-axis. That would give us the area under the curve, and that would give us the total amount of oxygen consumption. So this is a common type of question to get you to want to calculate the area under the curve. You would definitely do that on multiple occasions during the real exam. So, when it occurs for the Mary fowl between day 50 and day 60. So between day 50 and 60, I would put the average oxygen consumption per hour. Let me put for A, this is question 32. So the average oxygen consumption per hour, I would put about 60 milliliters per hour, and I would multiply that. Well, it's about times 10 days. Now you would actually have to multiply this by a factor to turn those days into hours. I'm going to write that factor as blah blah because they're all going to have to be multiplied by that same factor, whatever that factor is. Okay, so it's going to be converting days into hours, which is 1 day is 24 hours. So you have to you would have to do that to eliminate days, but we're not going to do that because it's all going to be the same for all the answer choices. So we're going to look at B, and we're going to look at the average oxygen consumption for B over the time period between day 15 and 35. So between 15 and 35 for the brush turkey, 15 and 35 for the brush turkey, I'm going to give it around 20. So around 20 milliliters per hour, and it's times whatever, 20 days. 20 days, and then it's the blah blah. And then C is going to be it's going to be average around 10 and for a period of about 30 days. Okay, so this is just giving ballpark numbers. Now, just by looking at this, you could see that A is going to give you the highest number. Yeah, so A is going to give you the highest number. So no, it doesn't matter what blah blah is. You don't have to make that calculation because no matter what it is, because if you're doing it to all three, A will always be will always be the right answer. So 32 is A. I have to warn you though, because I'm sure that some people, I would actually believe that many people get 32 correct just because 32 has a curve that is highest. The answer is not correct because 32A with the Nelly foul is the curve which is highest during that period. That's not why it's correct. It's because it's the factor between the value being highest and the time period. It's that factor being highest. So it happens to be the correct answer. So 32A. So next is 33. So now, according to figure 1, the estimate is close to the total amount of energy produced by the Nelly fowl 60-day incubation period. Okay, so the approach here is, it is a sigmoidal curve, but you can look at it and see that it's sort of shaped like a triangle. So I'm not sure if I can draw a triangle, but we will see. No, I can't. I can draw a triangle, but the triangle doesn't look anything like the one. So I guess I'll just try to put some lines together. So more or less, you can see the curve looking something like this. Oh, I should have done that last part. But anyway, there we go. So anyway, the curve looks something like this. And now, why are we interested in area under the curve? Because that will give us the oxygen consumption. Notice, answer choice, the question 32, made you, or should have made you, think about the area under the curve, but it was a simple question. 33 is now saying, okay, you looked, you understood that we made you look at the area under the curve. Now we want you to calculate something based on the area under the curve. So having done one helps you for the other. So now, how do you calculate the area of a triangle? So it is expected that you know that the area of a triangle, because you learned this in grade 5 or 6, is 1/2 base times height. Okay, so it's 1/2 the base of the triangle, the bottom, the x-axis, times the height, which is the y. Now, even if you didn't know that, you should at least be able to calculate the area of a square, which is x times y. And if you calculate the area of a square, well, look, magic. The area of the triangle is half of that. So it definitely is expected that you calculate the area of the triangle, so 1/2 base times height. And so now we just have to look at the base and height of them. Maui, is it Maui or the, okay, yeah, the Maui. So at 60 days, Maui, so now we have to look at where does the triangle start. It's up to you, you know, let me just make sure we have a couple of minutes here to finish. So it's up to you where you want to start the triangle, but, you know, maybe perhaps the triangle starts at around 10 and it ends at 60. But it definitely ends at 60 because that's the information we're provided. So if it starts at 10 and ends at 60, that means the number of units for the base is 1/2. So let me get back into writing stuff here. So we're going to have 1/2 the base of the triangle, which is 50 days, times the height of the triangle, which goes up to about 0.3. Okay, we don't have to be too precise because we can just look at the answers and see how far apart they are. So, and this is 0.3 joules per second. Okay, now, however, we need to, we're looking at an answer in joules, 60 days. Now, we have days times joules per second. So the days don't get rid of those seconds yet. We have to find a way to convert those days into seconds or the seconds into days. So we can do that by saying that there's 60 seconds in a minute. So we have 60 seconds in 1 minute. Okay, well, I'm just going to put in a minute like that. And that would eliminate the seconds. So seconds would cancel. So now we will end up with per minute. So we need to get rid of the minutes. So we do that by saying that there's 60 minutes in an hour. So 60 minutes in an hour. So that will cancel the minutes. And now we'll have hours below. And then we need to convert that to days so that we can end up canceling days. So there's 24 hours in 1 day. So you see, don't forget, no calculator. You're setting this up. There's no equation that you really need to memorize other than, of course, you should know the area of a triangle. And reading about respirology or cardiovascular anatomy will not help you get this question correct. Okay, so this sets up the math. This will end up getting joules because everything else cancels. This is dimensional analysis. And so now I'm just going to, you can calculate this any way you want, okay? It's up to you. So I'm just going to tell you the way I would think it through. So I would say 1/2 times 50 is 25. And I would say 25 times 0.3. So that's 7.5. So 7.5, though, doesn't help me. I don't like to deal with decimals when you're calculating lots of numbers together. Because I see a 24, I see 6 times 6 is 36. I don't want to calculate 24 times 36 times 7.5 during an exam when time is precious. So there's just no time to do that. You can do it, but I don't recommend it. So I have 7.5. So I know that 7.5 is 3/4 of 10. Now, 3/4 helps me because when we have fractions, when we're dealing with fractions, fractions can cancel. So I have 7.5 is 3/4 of 10. So that's what I've reduced the first part to. Then the second part is, it's 60 times 60. That's easy to deal with. It's 6 times 6, which is 36. And then we have 2 zeros. So that's all easy to deal with. And then we have 24. Okay, now I see that I have 36, and now I can add my extra 0. So I have 1, 2, and 1 extra 0. And then this last part, I have 3/4 times 24. So I use the common denominator of 24 and 4, and that gives me 6. So then I have 6 times 3, which is 18. So then I just have to multiply, and I get about 650. But this is joules. So that's 1,000 joules. So that would be 650 kilojoules would be the estimate, which means the answer would be C. So 33, the answer is C. Now 34. Which of the following features present in the strictly least likely to suit the bird? Oh, that it's unusual incubation environment or parenting approach. So unusual incubating environment. So the only information they provided about what's so unusual about their environment is that there's this weird, the oxygen level is very low, compared to normal oxygen, and the CO2 levels are relatively high actually. There's also the heat. And there's also the absentee parents. I mean, I think that Australia might need some brush turkey social services since they have these eggs and then they leave them to their own devices. They don't actually raise the birds. So these are things to keep in mind. So when we look at the different options in terms of their incubation environment and parenting approach, which is very diplomatic to say. If you look at, process elimination, looking at D, relatively large yolk supply compared to other birds, yeah, you would expect these birds to have a relatively large yolk supply because they have to feed themselves because their parents are not going to be around when they're born to take care of them. So they'll have to fatten up as much as they can in order to be able to fend for themselves. And C, large feet suitable for digging. These guys are born in a mound of trash, in the middle of a hot mound of trash. What a way to start their life. And yeah, they have to get out once they get out of their egg. And having large feet suitable for digging seems to be helpful because they're not going to have a parent to dig a hole to help them get out. And a thin eggshell seems like that would be also helpful to be able to break on their own because if the bird is struggling to get out, they're not going to have a parent or somebody to help them. So thin eggshell helps. And then the egg tooth, well, it doesn't happen often with the GAMSAT, but it specifically says in the passage, paragraph 1, 2, 3, 4, 5, in paragraph 5, that the brush turkey embryo has an egg tooth, which can be used to break out the shell. However, it primarily uses its large feet to break. So the egg tooth can be used, but it is not a primary requirement for the bird. And so what is least likely to specifically suit the bird of all birds is the egg tooth. So 34, the answer is A, and now 35, which is our last question for today. Okay, so now, hopefully when you've done this passage or whatever, and you know how much ACER loves opposites, and you know, you might have been alerted to that statement in the first paragraph, and you might have underlined it. And so this is where it states that at ground temperatures below stable incubation temperature, the rate of heat production in the mouse faster, blah, 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 and the reverse is true, and da, da, da. So, okay, so question 35. So now we're going to need to break this statement down into something that, you know, that's easy to digest. So, at ground temperatures below the stable incubation temperature. Okay, so let's look at that. At ground temperatures below the stable incubation temperature. Okay, so this is the first part of the statement that's provided. It's talking about ground temperatures below the stable incubation temperature. So if we have a ground temperature at the location VA minus the stable incubation temperature, this is going to be a negative value because the ground temperature is below the stable. So we're going to end up with a negative value, and this is the x-axis. So this provides us, so this x-axis is negative. Okay. So now let's look at the next part of the statement. The next part of the statement says the rate of heat production in the mound is faster than the rate of heat loss from the surface of the mound. So now let's interpret this part. So the rate of heat production is greater than the rate of. So now this is referring to the y-axis. So if the rate of heat production is greater than the rate of heat loss, this means that the heat produced in the mound minus the heat lost from the mound is a positive value. Okay, so now we just need to look at A, B, C, and D and see where do we find an answer choice in which the x-axis is negative while the y-axis is positive. So it has to be the x-axis is negative while the y-axis is positive. So we need to find that answer choice. And hopefully you can see that there is only one answer that's consistent with that, and that's answer choice D. Okay. What I'm hoping that you would see by looking at these questions and going through these questions is that you don't do what some people do, which is to spend months studying biology. And some students will study biology more than any other science subject because it appears that there's so much to be responsible for. And they do expect you to have reviewed a lot of information. But the key thing is that you look at the types of questions, you practice with them, and you really understand it. Like, you don't just look at the area under a curve and say, oh, wow, it's a triangle. Oh, that's good. I got the answer, move on. But you think about it. You think, oh, so they can ask me a triangle. Oh, maybe on the real exam it will be a rectangle, or it will be a square, the area under the curve. Look at the different ways. Think about the question. once you complete it and you find the right answer. Don't just think, oh, I got the answer, move on, but think, wow, this is one of ACER's practice questions. This is the style of question that they like to ask. So much of it is dependent on my understanding of the passage and to get into the habit of using those reasoning skills in order to solve problems. Okay, well, we're done for today, so good luck with your studies.